Well, good morning. I think you've sort of seen or heard to my lectures on basically in accounting. Today, we have a distinguished guest who would sort of talk to you more about the forensics, the applications of basically the course itself, where you will be using the course in terms of for fraud detection, etc., etc. So today we have Mr. Venkat Subramanian, who has joined us. He's from PayPal. He's the director of machine learning in PayPal. Venkat has a rich experience working with PayPal as well as Mu Sigma, etc. He is a visiting faculty at IIM Calcutta as well as XLRI. He's basically a MBA graduate from IIM Bangalore and an engineer from Guindy College of Engineering. And he sort of enjoys working on ML, especially in the fraud detection space. I mean, we thank Venkat for, I would call him Venkat than the full name. So, Venkat for joining us. And very nice of you, Mr. Venkat, for joining us and spending time so that our students can understand the applications, because they've done the course more on the theoretical side. Yeah. Now, what is the use of this course? Where is it that they can apply? That is what we want them to understand. That's the reason for inviting you over.
Thanks a lot, Professor. Really happy to be here and share my practical experiences from the field on how we use ML in different areas of fintech like PayPal.
Right. We'll try and have an informal chat more to understand. Now we talk about PayPal, etc. Right? I mean, it's how different is it from a regular or a traditional bank? Because people know that fintech means I sort of use technology for my banking operation, typically any of the banking operation. Now, PayPal in that sense is not a typical bank.
Correct.
Right? So, how do you even distinguish the fintech, especially in these space of PayPal, etc.?
Sure, Professor. I think there are multiple dimensions in which a bank will differ from a fintech like PayPal. I'll probably cover a few of these dimensions, right? There are a lot of similarities, but I'm going to focus a bit more on the differences to start with. One will be the business model, right? Like a bank has a wide variety of different areas that it takes care of, like giving loans to customers, taking deposits from customers, offering other products like insurance and whatnot. So there is a spectrum of financial services that a bank provides. On the other hand, a company like PayPal focuses on one specific area called payments. Just purely enabling payment from party A to party B in the online world. That is the core specialized focus area for a company like PayPal. So that I will call as a one core difference. Second is the level of technology usage and integration. Right? If you think about a bank, today of course banks are also getting more modernized. You're seeing internet banking, mobile banking and whatnot, right? But still there is a lot of human element there. You go to a branch to do something, there is a person that talks to you and so on. But in the case of PayPal, it's almost 100% technology driven. Mm-hmm. For a customer, unless when they have a complaint and call a call center or something, right? There is really no human interaction. It is all driven by technology purely in real time, right? The best way to explain this is, let's say you're purchasing something online from say an Amazon or a Flipkart or something, right? On the point of checking out, right? You want to make the payment. Say it's 1,000 rupees for a pair of shoes. Okay, then you just click PayPal as a wallet like Paytm in India, where you click that option to make that payment. And the payment happens in a matter of milliseconds, right? That is exactly PayPal. That in the background, PayPal is acting as a secure payment provider for you to enable the transaction.
How does it compare with, for example, say, I use a credit card for payment. You said Amazon.
Correct. Yeah.
Right? I can use credit card for making the payments in Amazon if I buy on Amazon, whatever.
Correct.
So how does the PayPal differ with use of a credit card in terms of technology or in terms of the operation itself?
Correct. Good question, Professor. So basically, in terms of the fundamental usage, both are the same, right? Okay. Credit card is enabling you to make a payment. PayPal is also enabling you to make a payment. The only thing is PayPal, I would call as a more value-added service on top of credit card, because let's say you have multiple credit cards and multiple different debit cards, right? Each time, you may not feel comfortable entering all the details into some website, right? Like, okay, Amazon is a trusted website. Sure. What if it is some other mom and pop store online, right? So there is that element of both convenience and more importantly, security, right? Am I comfortable sharing this information with some website? That is exactly where a service like PayPal comes into picture, because you create one PayPal account You enter all your different card details into it and it is stored securely for you.
Okay.
Thereafter, whenever you are making a payment on any website, you just like click the PayPal, log into PayPal during the transaction and select the appropriate card. Then the transaction is taken care of for you.
Okay.
The additional advantage I would call in this is that PayPal also offers something known as buyer protection, which means that let's say something goes wrong. Say you order an iPhone from some unknown website and finally you end up getting a brick. Now, who is going to take care of this for you? PayPal will take care. PayPal offers something called buyer protection where it says, if something goes wrong, I am going to refund you the whole money. Okay. So in this way, essentially, to answer your question, PayPal is like a credit card only in terms of basic functionality, but it offers a lot more convenience and more importantly, security and safety on top of a regular transactional instrument.
Yes. Okay. Yeah. Now, when these things happen, when we use credit cards, etc., there's a lot of frauds, etc. Yeah. That is what is associated with.
Correct.
So, is that sort of minimized when you use PayPal, especially?
Exactly. In fact, that's one of the areas we wanted to cover in this session, right? So, when you look at PayPal, right, PayPal is not unique in this space. There are many different companies that are operating, right? Paytm in India, yes. Like MobiKwik, Google Pay and whatnot, right? There are so many payment providers. One of the main challenges for all these providers is that it is very easy for a fraudster to hack into this space, right? Fraud can happen in multiple different ways. Somebody can use your PayPal account because, see, as I said, your PayPal account has all your credit cards, debit cards, everything about you. Let's say somebody's hacks into your account and then uses your username and password to buy like 1,000 things online. So that's a fraud. Let's say somebody has stolen your credit card, which is already part of your PayPal account, and then they're using those credentials to make a transaction. That is also fraud. So fraud, in fact, I'll cover it more later in detail. So, sure. But online fraud is such a commonplace thing today, and it's very frequent. And that is where a company like PayPal provides you an edge because PayPal has intelligent ML algorithms and data behind, which helps PayPal to prevent fraudulent transactions right when they are happening.
Now, since you've started in the aspect of fraud, what are the different kinds of fraud that can happen? I mean, more for our students who have sort of done this course on forensics. Because, how can they use technology for detecting? First of all, let's understand what are the different kinds of fraud.
Correct.
Then maybe we will superimpose the technology part to detect these frauds.
Yeah, I think that's a good way to start, lay the foundation, right? So the fraud, I would categorize broadly into two parts. One is a buyer fraud and the other is a seller fraud.
Okay.
So any transaction has a buyer and a seller, right? Be it in the online world or the physical world. Now, either of these parties can be a fraudster. So let's first look at the buyer fraud where the buyer is a fraudster. Okay. Now, first type I would cover is what is known as account takeover. It is abbreviated as ATO. What is account takeover? Say you are a genuine buyer. You have a PayPal account in your name, but somebody without your knowledge has taken over your account and password. Now they are transacting on your behalf and you never realize this, right? Suddenly, and they are, of course, as I said earlier, they are using some credit card or debit card within your PayPal account to make all these transactions, right? And the reality hits you when you look at your account statement next month, that you're seeing like some 1,000 transactions which you never knew of, right? So that is known as a classic case of account takeover where somebody is stealing your credentials. The other type of buyer fraud is what is known as stolen financial, where your PayPal account is still yours, you're logging in and everything, but the cards or funding instruments within that account, right? Somebody has stolen that. Let's say you put your credit card somewhere and somebody has taken it, right? They are making that transaction using that card, which is also linked to your PayPal account. That is known as a stolen financial kind of fraud. The third kind is, all of these are okay, right? It's your account, it's your card, everything. Nobody has stolen anything, but you yourself have a bad intent. Okay. This is different from the first two kinds because first two kinds we call it a third-party fraud because you're the first party, but you're a good guy.
Okay.
Somebody else is using your account to do bad things, right? That's third-party fraud. In the first-party fraud, you yourself have a bad intent. Right? So, which means that you can abuse the PayPal-like system in multiple ways. Let's say, for example, you order something from a website. They have actually delivered everything, the iPhone to you rightly. But then you go and register a complaint with PayPal saying, hey, I received only a brick. You have to refund me for that. Right? And that is known as first-party fraud or buyer abuse, where the buyer is intentionally abusing the system.
Okay.
So, these are a couple of different examples and there are more. Probably we'll do it more in detail later on the buyer side. Now, you come to the seller side. See, seller again, I think in India it's probably not very easy to imagine this because we are new to the online shopping world.
Sure.
And most of us are comfortable with our very well-known Amazons and Flipkarts,
Yes.
right? But if you look at a country like US, online shopping has been there for more than a couple of decades there now. And they are used to shopping from other countries also. A lot of people in US buy stuff from, merchants in China. So they'll go to some Chinese website. They'll find that, iPhones are selling, some fake iPhones are selling for like, only $50. So they'll buy it, right? It's a very common example. Now, in this case, the seller can be a fraudulent guy. Like I said, that same brick example I gave, the seller can be actually doing that, getting the money from you, but giving an item that is really not an item at all. So that is one case. The other case in which the seller can act bad is that he can ship the regular item, he can get the payment, but finally he can come and tell you PayPal that, hey, I didn't receive the payment at all. Somehow the payment is not credited to my account. You have to refund me for this.
Okay.
So these are different ways in which bad actors can sort of abuse the system. I'll just give one more example. There is we talked about buyer, we talked about seller. There is an example of fraud where the buyer and seller can collude together. Okay. So imagine you and your friend decide, you understand that PayPal is refunding for anything that is going wrong, right? So then you decide that, hey, you open a website. It's called, say, some consulting services website. And then I am supposedly taking a consulting service from you. And then later I will go and tell PayPal that, hey, I didn't receive any service at all. Yes. So you have to do it. So in this case, it's called buyer-seller collusion. So there are multiple ways in which fraudsters can come, and this is like a huge business out there. Okay. In fact, in what is known as a dark web, apparently real financial credentials of people are available for like $10 for 50 credentials and so on. So it's a huge industry. It's almost like an organized crime industry. Yeah. So you need really a lot of technology and muscle power to sort of be vigilant and prevent it.
Because you already discussed about 6 to 7 different kinds of frauds, both on the seller side as well as the buyer side. And you must be dealing with the multi-million transactions, right? Yeah. So are there patterns, or how do you detect, or can technology help, and how does technology help in terms of ML and AI and stuff like that? Or can you elaborate a little more on that?
Sure, sir. So I think there are some patterns you will always find, right? Now, the how part I'll go in slightly later, but what do we mean by patterns, right? Let's say there is a transaction happening from your account at US morning time. Okay. Which is India night time, let's say around 12 in the night, right? Fine. And for a $200 value. Now, it's already looking suspicious. Okay, a lot of times, you will see that even when you're using a credit card, let's say you try to use your credit card in the night time, sometimes the transaction will not go through. Okay. Or you might be asked for additional authentication, like an additional OTP, or asked to confirm your date of birth, right? Why are these things happening? Because this transaction pattern is unusual to your account. You're a person who normally only transacts during the India daytime. Okay. On items of a specific category of a certain value. Now, suddenly something is unusual in your account. Then the payment processor, be it PayPal or any credit card company, gets suspicious, right? They will try to authenticate whether it is a real you. Okay. So to answer your question, the first thing that comes to mind is unusual transaction pattern from any particular account, which is inconsistent with how that particular person normally transacts. Okay. So this is a signal, right? Now, how do we detect this signal? I'll come in shortly, but this is one way in which a pattern can be identified that something is unusual, right? Now, I also want to call out that this can be genuine also. This can be genuine. You could be actually traveling. So this alone cannot be a single, I cannot say that, if the transaction is happening at 12, in the night, then decline it, right? Yeah. It has to be. So there are multiple other factors you will have to combine with to see if this is to confirm if this is a genuine fraud or not. The other way in which you can find is a lot of hacksters, right? They typically play with the technology. Okay. Okay. For example, let's say I'm a fraudster. I'm using my personal computer at home. It has a certain IP address and it is connected to a certain network. Now, once I can do this, I can steal somebody's credentials, make a bad transaction, right? You won't know. But within a month, the actual customer would have made a complaint to PayPal. Now, PayPal knows that from this particular IP address, from this particular device, somebody wrong is transacting. Okay. So it will already try to blacklist that particular IP address, right? Now, that is why a lot of fraudsters and hacksters, what they do is, they don't use a real system. They use known as what a virtual system. It's also known as VPN or whatever, right? Where you create an like sort of an image-like system whose configuration will keep changing dynamically. So the IP address will keep changing, the device ID will keep changing. Every time they will create a new virtual system from which they are transacting. But even that virtual system also, there are parameters, technical parameters through which PayPal can detect that it is not a real system, but it is a virtual system. Now that again is a red flag, right? Why will a genuine transactor ever use a virtual system to make a transaction?
Yes.
So I think this is another way in which you can identify. The third thing will also be that a combination of these factors. Look, okay, what do I know about this account? How consistent has the transaction been? Plus, what is the regular IP address or device I associate with this account? Is something new or unusual happening? So these are the kind of elements in which you can identify patterns that you identify fraud
So
with.
there are multiple aspects which you keep correlating.
Correct. Which I keep correlating.
Okay, that's quite a challenge, especially when you're dealing with multi-million transactions every
Exactly,
minute, right?
Now, so there are different ways to now coming to the how part of it, right?
Yes.
So these are the patterns, right? Now, how are you going to, as you said, multi-million transactions happening in real time? It's not like I have somebody sitting and scanning each transaction, right? I don't have the liberty or luxury.
Yeah.
So I can do different things. One is a simple known as rule-based approach, where I use certain rules or combinations of rules to flag high fraudulent, high likelihood of fraudulence in a transaction, right? So the rule could be something like, if the system from which the transaction is coming is a virtual system,
Okay,
or if the IP address is from a list of listed IP addresses, or if this particular say device ID or geographical ID has some negative activity associated in the past,
okay,
or if this particular merchant with whom the customer is transacting has a history of bad guys transacting, right?
okay.
So from experience, by analyzing the data, you could create rules using what we call as variables, right? Like each thing is called a variable. Like the IP address associated with the transaction is a variable.
Yeah.
The regular time, let's say the normal average time at which a particular account transacts is a variable. So you will have multiple variables that are being computed in real time for each transaction. Now you could create a bunch of rules with and or whatever logical conditions to say that, hey, if all these conditions are met, then there is a high likelihood that this is a fraudulent transaction. You decline it.
Okay.
Or if some of these conditions are met, some are not met, maybe it's somewhere in the gray area. Maybe you do an additional manual review.
Okay.
Like put it on what we know as pending, call as pending, and then approve the transaction later. Or maybe you would have had this experience, right? Sometimes you're asked for an additional do you remember your date of birth?
Yes.
What is your favorite pet name or something, right?
Things like
something is suspicious, but I'm not 100% sure, so I want to do that additional step of authentication. Or if not everything is good, everything is green, then allow the transaction.
But then, as you said, because especially it's a challenge when the fraud setter or fraudulent guy will also be doing will also be sort of going one step above you, right?
Correct. Yeah.
And you said that if there is a transaction which is happening at the odd time, then there is a flag. But now they know that there would be a flag, so they might avoid doing these kind of things also.
Correct. Very true.
It's a one-upmanship, right? That is
exactly.
It's a very simple thing.
Yeah, this is which is exactly why this is a very dynamic and constantly evolving field. You have to always be one step, ahead of the fraudsters, because as you rightly said, in fact, they are always trying to be one step ahead of you. So one thing that helps, and here is where I will bring in machine learning and ML, is that the rule-based approach I talked about is a bit static. Somebody has to manually keep screening the data, understanding the patterns, and create these rules manually.
These rules also have to keep dynamically changing. Correct,
right?
Because
today one IP address may be bad, tomorrow they would have created 1,000 more IP addresses, right? Like, how am I going to screen all this and keep? So which is exactly why, instead of going with a rule-based approach, an ML-based approach, what it does is, it finds these rules dynamically for you. What do I mean by that? Let's say you feed into an ML model all examples of past transactions that turned out to be fraudulent.
Okay.
Let's say in the last 2 months, you approved 20 million transactions, out of which retrospectively, you would have learned that, hey, out of these 20 million, around 1 million turned out to be fraudulent transactions because you received, actually that's a high number, I'm just giving as an example. Normal fraud rate is something around 3% or 2% of transactions.
Okay.
Yeah, but let's say some percentage of this is turning out to be fraudulent, right? This data is not available to you at the time of transaction, obviously, right? If you had already known, you wouldn't have even allowed it to happen. you will know it retrospectively based on a customer filing a complaint to you. Okay, so you have that label now. This is what we call as the label data, right? Out of 20 million transactions, I know 19 million are good. I will give them a good label. The 1 million are bad, I will give them a bad label.
Okay.
Now I feed this whole set into a machine learning model. Now think of if you have done some examples of models already, right? You will know there are classification models that help you split a data into 2 or 3 different classes, right? Examples are something like logistic regression or a decision tree or a gradient boosted decision tree. So, the multiple varieties of classification models. Now, basically, you take this whole set of data, you feed into the model, and then the model figures out what is different between the 19 million transactions that were good and the 1 million transactions that were bad.
Okay.
Like what variables were different? Was it only the IP address? Or was it a combination of IP address and device ID? Or was it a combination of IP address, device ID, and the kind of item that was purchased? Or maybe it also has to do with the hour of the day in which the transaction happened, right? So for any transaction, you'll have thousands of what I call as variables like this, like hour of the day, transaction item, merchant, customer, and so on. So the machine learning model will essentially try to use all these variables to create its own rules, or what I will call as a decision tree, which says if this condition is satisfied, if this condition is satisfied, but if this condition is not satisfied, then the probability of the transaction being a fraud is like say 0.6. If a different set of conditions are satisfied, then the probability is say 0.4.
Okay.
So like this, it is going to create this decision tree itself instead of you creating the rules based on your wisdom and knowledge.
Okay. That means there has to be a constant training of the system.
Exactly. Exactly. So even if you use a machine learning also, let's say it creates this wonderful big tree for you, which has a complicated set of rules, right? This pattern will also change because the fraudster is also somewhere realizing and is evolving, as you rightly said. So you will have to retrain the model. So today, let's say I train the model based on last 2 months of transaction data based on what is fraud and not fraud. Down 2 months, this model may no longer hold good because there are newer patterns that are evolved. So you will have to constantly retrain the model. In the PayPal world, we have what is known as a rapid model refresh paradigm, where we retrain the model almost every couple of weeks regularly.
Okay.
And the only challenge here is just simple, it's not an automated system which retrains itself, because somebody has to still give a once over to the model to make sure that it hasn't learned something wrong or it is still functioning correctly and the performance is fine. So we do have a process where there is a manual check-in of the final refresh model.
Okay.
But it is, like you said, because the space is very fast evolving, you need to have a process that refreshes or rebuilds the model itself every 2 weeks or so.
But over a period of time, the number of models what you would have or what would form patterns in terms of would be huge, right? Because every 2 weeks you're having a new pattern or a new model evolving and you're adding to it. I think over a period of a couple of years, I would have some 100 different, 200, few hundred more different models. So number one is that, and how does the technology take care of going through all that? Number two is, can these models sort of go into a loop where it can sort of even put in a correct transaction into them, because there are different kinds of models, right? One model would say these are the parameters and the other model would say completely different parameters. So there could be some kind of a conflict between these models. Possible, I don't know.
Definitely.
Because I'm not from technology background. So, and can that basically throw you into a loop wherein you're even and pulling back the right transaction or the correct transaction? What is the probability of such things happening?
Very good question. Actually, you covered 2 different dimensions. So let me try to answer both, right? So one area I want to go before I answer your question is, see, a model doesn't give you a label like good or bad. The model is not going to tell you this is fraud and not fraud. All the model is going to do is give a probability estimate saying that, hey, this transaction I think is 90% fraud. Another transaction I think is only 30% likely to be fraud. Now, there is a layer called strategy, which decides what is an acceptable threshold for me to threshold of risk that I'm willing to take. What do we mean by threshold? Let's say one transaction is being flagged as 10% likelihood to be fraud. Is 10% a very, very high likelihood? Maybe not. So do I allow this? Okay, maybe my strategy will decide to allow this. But even in this, there is a 10% chance that it turns out to be fraud and my decision was wrong.
Wrong.
So that error of this thing is always going to be there, because you have to draw the line somewhere. You have to decide what is the probability threshold above which you are going to call it a fraud and below which you are going to call it a good transaction and allow it, right? So this is a strategy layer. Now, when you do this, of course, there is a retrospection that you will need to do to understand whether this model and your rule work well together or not. What is the sense of truth for you? Let's say you put this thing, there is a new model and there is a rule like this, right? Above 0.9 is fraud, below 0.9 is not fraud. You put this in operation for 2 months. Then you would have allowed a certain bunch of transactions, you would have declined a certain bunch of transactions. Yes. For whatever you allowed, somewhere later a customer is going to call you if it happened to be fraudulent, right? He or she is going to make a complaint to you. So you will know that, hey, this is actually a bad transaction, but somehow my model said it was a good one. And my cutoff threshold also allowed it, so I allowed it. So it's a wrong thing. Similarly, on the other side also, let's say you didn't allow something to happen. That is actually less straightforward. If you didn't allow something to happen, you will never know whether it could have been good or could have been bad.
Yes.
I'll come to that part later. But assume, let's say you have a way to figure out whether it's good or bad. So then you essentially, what your model predicted and what the reality was, you have this sense of truth down 2 or 3 months, right? So this is what I call as a model performance measurement. Now, like this, I can use there are metrics that are called like KS or AUC, which combine all of these, good versus good, bad versus good kind of performance measurement into one single number.
Okay.
So I can say that one model KS is around 55, which means that it's actually very, very tough to describe this KS metric intuitively, but just assume that it's a measure of the accuracy of the model. How right it was whenever it said the transaction was good, and how right it was whenever it said a transaction was bad. So like this, for one model, I'll have the KS as 55. Say for a newer version of the model, I have the KS as 60.
60, okay.
So only when the newer version is better than the older version, first of all, I'm going to take a call to replace the older version with this newer version.
Okay.
This is coming back to your question of, okay, how do I manage all these 200 versions of models?
That's true.
I don't really have to maintain all that. As long as, say, today's version is better in terms of this performance criteria compared to all the prior versions, I'm going to discard all the prior versions and maintain only this newer version. And tomorrow, down 2 weeks, I will create another newer version. It may or may not be better than this. So then I will discard that. So at any point of time, the best performing model alone is going to live, and everything else is going to be checked off.
Checked out, okay.
Yeah.
Okay.
I think the other aspect, again, as I want to reiterate, is the strategy part. Refreshing the model, as I said itself, is once in 2 weeks, right? But strategy can be faster. The threshold I use to decline or approve a transaction can be faster. So using the same model, today I might be approving all transactions that have a probability greater than 0.9. Tomorrow I can say that, hey, that rule is turning out to be a bit too lenient. I'm seeing more frauds happening because I draw this line here. I can simply tweak the system. Like it's like just turning a knob and say, hey, the cutoff is 0.8 instead of 0.9. So then I'll be a bit more stricter in terms of how much I am declining versus approving.
But there's always a human element there, because you got to look at the business aspect as well as the threshold level, right?
Correct. Yeah, good question. This is the other dimension I wanted to cover, right? So what is the trade-off here? Okay, so let's say I want absolutely not even a single fraud transaction to happen. I want to do the best for my customers, right? So then even if there is a small 0.05% of chance of something be a fraud, I can easily go and decline it. But what's the trade-off here? Let's say in 95% of the cases, if the transaction is actually genuine, my customer is going to feel bad, right? There's a real customer trying to make a genuine transaction at the other end, and I am being super vigilant and cautious and trying to decline it, thinking that it is a fraud. Customer is not actually going to be happy.
True.
Similarly, on the other end, right, I try to make the customer happy and try to allow maximum number of transactions, then fraudsters are going to have a field day. They are going to make more and more fraudulent transactions. So that's why it's sort of like walking on a tightrope. On one side, you want to allow the maximum number of good transactions to happen to keep the customers happy. On the other side, you want to have the minimum number of bad transactions to pass through your system. You'll never be in a 100% perfect state, but somewhere you draw the line, you take the call, you look at, okay, how many frauds happen, how many good transactions were declined, then you keep tweaking your model and strategy. It's a human element is definitely there.
Okay.
Yeah.
So coming to the technology side, more for the students who have done this course on forensics, etc. How can they use their learnings in the practical aspect. Maybe you could take an example of one of the frauds which you would have seen. Maybe we're not able to name, but in general. And then sort of if we can marry what they've learned, if we can superimpose on them, and how they can use it for detecting such frauds, etc. That should be helpful for them.
Okay. I'm assuming the students would have learned through like basics of ML models and data, what kind of models and all, right? See, I think one difference I would definitely call out between the, when we learn in a classroom setting versus in the real world is that in a classroom setting, the data is generally very clean and nice for you. Right, you're typically handed over the data in a CSV file.
Well, can you even define the data? That is even better, because can you even define the data so that it's easier for them?
Okay, let's probably take like imagine a situation, right? Let's say you're a new payment processor. You're starting today, 0.0. You don't have any data with you. So in the first 1 month, or let's say first 2 months, you're accumulating data. What do you mean by accumulating data? You're having transactions passing through your system, right? For each transaction, the data set, you can create what is known as variables. Okay, what is the transaction time? What is the transaction's IP address? How much dollar value was the transaction? Who was the sender? Who was the receiver? Was the transaction paid through a credit card or a debit card? What kind of card? All these are what I would call as variables. In terms of a machine learning model, I will call them X variables because they are what is known as independent variables, which help you predict something. Okay. So for any transaction, or like in terms of, let's say I have a customer level model, the same thing I would define in customer level, right? Okay, what is the customer's age? What is the customer's tenure within the PayPal system? How often does the customer transact in a month? All these are again variables for a customer level model. In a transaction level model, you will have variables describing the transaction. All these are what I will call as X variables. On the other side, you have your Y variable or dependent variable, which is what you are trying to predict. In a fraud world, typically the dependent variable is what is the likelihood of a transaction being fraud or non-genuine, right? Just to give another example, let's say you're in the credit risk world, right? We also build credit models. In the credit world, the Y variable will be what is the likelihood that somebody repays their loan or not repay, right? This is exactly that variable, or data point you're interested in. Everything else you're feeding is helping you predict this Y variable. Okay. So when I say, coming back to the original point of what is a data set, right? Let's say you're a new company. In the first 2 months, you got 1 million transactions flowing through your system. Now, imagine an Excel file with all these million transactions laid out in like one row after another for million rows, right? Now, for each transaction, the columns are going to give you all these variables. Okay, for transaction 1, this is the time. This is the dollar value. This is the time, and so on. So this is your data set.
Okay.
So in an academic world, typically we don't let students create this data set, right? We give them the data set. And then all they have to do is, okay, given these variables, these columns and rows and whatnot, I have to build a model that does the required job of, predicting a fraud or predicting a credit.
But in a typical real life situation, these data, whatever you described on an Excel sheet in terms of rows and columns, will not be very, very sequential or accurate, right? You will have to do a lot of cleaning, or you will have to sort of do a lot of readjustment because the transactions are going to be different. Would that happen?
Correct, absolutely. So the transactions, okay, in a systemic world like PayPal, the transactions are going to be consistent in how they look to each other, right? What variables I am capturing. But there's a lot of work involved in even putting this together.
Yes, that's what
nobody is going to give you an Excel sheet or a nice thing, right?
It will have different currencies.
Exactly.
That itself will not be, somebody will have to sort of get all that to a same base or a same currency, right?
And there are multiple systems that are talking together to even make a transaction happen, right? For example, for a transaction, all the customer related variables might be coming from a customer level database that is sitting in, let's say, some sort of SQL based system. The real-time transaction-related data points might be coming from a real-time system, which is happening in a different technical architecture, right? Something around, let's say, the past fraudulent behavior, or might be in some other big data, what we call as a Hadoop-based database, right? So there are different kinds of databases. Some are real-time databases, some are transactional databases, some are archive historical databases, where all these data points are sitting.
Okay.
All these data points, when they are brought together, describe one single transaction. But even to bring them together, you need to find out the right way in which to get the data.
That's what.
Correct. There is another nuance I want to bring in here. When you are building a real-time model like this, your variables also have to mimic the world at that point in time at which you are trying to predict the fraud or not fraud for the transaction, right? Let's say the transaction were happening at 9 a.m. on 21st May. Now, the data set should reflect how the entire system looked at that point in time. You cannot take a future world of the data and then try to predict the transaction. So, this is another complexity that you will typically encounter in creating a real world data set to build a model.
Okay.
So, I mean, just to drive the point, so I have a team of data scientists who are working on these models. I wouldn't be exaggerating when I say that at least 60% of time in building a new model goes off in just creating the data set alone.
Creating the data set, getting all these things into a proper sequence or a proper frame.
Exactly. In a proper frame, in a proper format, consistent with each other, talking about the same transaction or the same customer, all from different system married together in the right way. So that takes a lot of work. That's why basic data manipulation, data wrangling, dealing with databases is a very, very fundamental skill for any machine learning scientist or data scientist.
Fantastic. Now, more up beyond this.
So once you get the data right, then you're going to think about what kind of model is going to best fit your world, right? As I said, the model is essentially a machine learning model or a classification model in this case, which tells you something is like, class A or class B, fraud, non-fraud, right? Credit-worthy, non-credit-worthy. So it's a classification model. But classification model is a broad umbrella. Within that, you have a whole gamut of different models you can build, starting from a very basic logistic regression model to something that is more complex like a decision tree, to the other end of the complexity like a neural network, right?
Okay.
All of these do the same job. Ultimately, they are telling you if something is good or something is bad. But the more complex models like neural networks typically have a higher performance. Right? What do I mean by performance? As we discussed earlier, accuracy, right? If the model says something is bad, how right it is going to be and how wrong it is going to be, right? So that accuracy typically is better for the more complex kinds of models. When you take something simple like a logistic regression model, you're still doing the same work, but you will notice that a simple linear model like that is not really good enough to mimic the real world fraud patterns, which are a lot more complex and non-linear and fast evolving. So typically we choose somewhere either a neural network or sometimes we go into a mid path between these two extremes, which are known as boosted decision trees, which is another technique to, classification model kind of technique.
These models are continuously being built, as you said earlier.
Exactly.
Right? Yeah. Continuously upgraded and continuously being built.
Correct.
Okay.
One other dimension maybe I want to call out at this stage, since we are talking about the types of models, right? This is also a trade-off like I talked about in the strategy layer. Here also we have a trade-off. As I said, a simpler model will have lower performance and more complex model will typically have a higher performance. But then that doesn't mean I will always choose the most complex model, because complex models also suffer from interpretability. So as I said, there are like thousands of variables going into the model, and finally the model is going to tell you something is fraud or not, like probability of fraud is like 75%, right? Now, why did it say this? What made a model say 75% for one transaction A and another, a different percentage, say 45% for a transaction B? Okay, you would have probably declined the transaction A, say because it's a very high likelihood of fraud, and approved the transaction B because it has a low likelihood, right? But assume tomorrow a customer is calling you and asking, hey, I made the transaction A. I'm a genuine customer.
Yes.
Nothing is wrong, but you declined. Can you tell me why exactly you declined? Okay, you can try to give some simplistic answer like, hey, my fraud model declined, right? But he's going to ask you, why did your fraud model decline?
Yes.
So will you be able to pinpoint that specific data point or variable that made the model give that score?
Okay.
Was it the time of day? Was it the IP address? Was it some other element of the transaction, or was it a combination of elements? What made the model give a score? This is called interpretability. How interpretable are the model's outcomes for you to explain to a human being, right? Now, the more complex models typically suffer from interpretability. They are very good at what they do, but you will not be able to easily explain why they gave a certain prediction.
Okay.
So that's why the intermediate, on the other extreme, right, a logistic regression, you will always exactly know why it gave a certain score. You can always find out, right? So therefore, you try to balance. You try to sometimes take a midway where you have a better performance, but also a bit more of an interpretable model.
Okay.
So this is coming back to the flow we were going in. First, you created a data set.
Yeah.
Then you build the model.
Yes.
Then you debated between different models based on their complexity and accuracy and interpretability and all these parameters, right? Finally, is putting into action. you put into action, as I said, with a strategy layer where you decide what is the cutoff on the model score you're using to approve or decline transactions, right? So the model is now operational. But your job doesn't end as a team. You'll have to constantly keep looking for how well the model is doing in real time.
Okay.
Is a model score consistent over a period of time? Suddenly, you might see that, hey, model score is like, dropping to some unusual levels, right? Average model score. Now, it could be genuine. Maybe because suddenly, there are no fraudsters or, these are very rare instances, right? It never happens. More often than not, when there is an unusual trend in the model score, you will realize that something went wrong in the data pipeline feeding into the model.
Data, yeah.
Like something broke, some process didn't refresh, right? Some data elements are not being refreshed. So the model score is dropping and giving some meaningless values. That means you're actually, because using the score you're approving or declining, you will be making the wrong decision. So you need to have this monitoring or alerting system that tells you whether everything is going well in real time when the model is being actually used for decision making.
Okay.
So that is one part. Second is the performance tracking part, as I said, right? All of it is still a prediction. The model told you whether something is good or bad. You made the decision. But based on real customer complaints and feedback loop,
You will
need to assess the performance. And if the model performance, model is not being very accurate, then you'll have to refresh or retrain the model and, deploy another version.
Yes. Yeah. So, but in this entire process, there's a lot of human element involved, right?
Correct.
So, for example, people working in PayPal will have access to my credit card, my entire details, etc. So, what level of control systems, regulations, especially comes in? Because there are a lot of regulations in the financial system also, right, of every country.
Correct.
So, and number two is the ethics part of it in these people managing. These are the two basic aspects.
Very good question, sir. So I think one is what we call as data privacy regulations, right? I think many of us would have heard, especially in Europe. Today there are known as GDPR is a whole new regulation that governs the data privacy of your financial data, especially with banks and these kind of fintech companies, right? Now these rules dictate that what are the allowable ways in which your data can be used by the financial company, and what are the ways in which it is not allowed. To give a very simplistic example, right? Before all these regulations came in, it was very, very possible that your bank took your data and gave it to some, say, insurance company, because, say, insurance company wanted to sell a new insurance plan. So your data is being shared with the insurance company, and suddenly you'll be getting a call. In India, even today it happens. We are all used to the spam calls that we get, right? But in Europe, and I think in many other regulations, that's why they took this call to make sure that they're going to clearly define what is an allowable use of data and what is a not allowed use of data, where the data can be shared, where the data cannot be shared. Now, in this world, fraud prevention is definitely one allowed, acceptable use case where your personal data can be used. But still, that doesn't mean anyone can use it. There are designated teams where people with designated roles who will be allowed access to this kind of data.
Okay.
Typically, in a model building phase, we don't need to directly access anyone's personal data. I think the ethical part, so one, as I said, is about privacy, right? So what data, how do you make sure the data is used in the right way? Who has access to personally identifiable data? We have a term called PII, which is essentially personally identifiable data points about a customer. And we make sure that only the required people who are building the model and where it is exactly needed, those people have access to the data. So there are a lot of these data governance protocols within a company like PayPal, which make sure data is not leaking to unwanted use cases or unintended uses. So there is a data privacy part that is taking care of the regulations around privacy. Second comes the ethics part and bias part, right? What do I mean by bias? Let's say unconsciously a model can make decisions where people from some certain communities or with certain characteristics are being adversely affected by the model's outcome. A good example is, for example, let's assume you're building a model that decides who will get a credit card and who will not get a credit card, right? Maybe it is possible that the model factored in gender as a variable into, and then it start declining more, say, women from its applicant pool, right? So these are real concerns around a model's ethicality and what is known as ethical AI. Now, that's why what we typically do again in the PayPal world is there is a governance group which scrutinizes every model and looks at all the variables that are used in the model to understand if any of the variables can cause a bias in a model's decision making. Right? Is a model trying to use somebody's locality to decline certain population completely? right? Sometimes this is intuitive. Of course, we will never use a gender or age or ethnicity in a model, right? But a lot of times this is subtle and unconscious, right? For example, I remember a case where in a model somebody used the category of products a customer is buying as a variable. Now, when we took it to the legal team, they had a concern that, hey, category of products can actually be a proxy indicator for somebody's gender, right?
Yes.
So let's say women are likely to buy, say, fashion-related goods.
Obviously.
Sounds like stereotyping, but the data will actually support it, right? Now, therefore, in a way, without directly using gender, you could use some other proxy variable that can cause a model to be biased. So there is a governance layer which looks at every model to scrutinize it for these kind of things, right? Now, this governance layer typically is stronger for some kinds of models, especially in the credit world. But in other words, even in fraud kind of models also, there is always a governance layer to make sure there is no fundamental bias or unethicality in your model.
But you just mentioned the legal team.
Correct.
So what is the influence of the legal team, or what is their sort of role in this entire fraud detection, the legal team? Do you sort of, every time there's a model, do they step in and then do they approve it, or does it have to go through them, etc., in a system like PayPal?
Yeah, as I said, I think the legal rules are, differ. The level of stringency will differ based on the use case. Like I said, in the credit world, right, whether deciding whether to approve somebody or credit or not, there's a lot more legal scrutiny. Every model goes through at least a 2 to 3 month review by the legal team before it gets approved for a credit use case. But fraud, as we said, is a dynamically evolving world and it is much faster moving. Nobody will have the luxury to wait for a 2-month legal review. That said, there is a governance team which looks at models on a periodic basis to understand, one, the privacy concerns, two, the ethicality concerns, but it's more like a periodical thing where let's say every 2 months, 3 months, they're going to review all the models and look for any red flags.
Okay.
So, but it is not going to be like a bottleneck because fraud prevention, at the end of the day, you're preventing a fraudster. So that takes precedence over other things.
Now, in terms of data sharing, for example, PayPal is one outfit. So can you share with similar organizations like PayPal? I mean, especially you have the fraudulent data, whatever. The data where you see that these could be fraudulent transactions. So can you share among at least companies who are in the same field or the same fintech field? Is that allowed? Because that could sort of add a lot of value. The reason for asking is if somebody else is doing the same thing and they're able to have identified some of the patterns and fraudulent transactions and share with you, then that saves a lot of effort for you as well as it could. Is that allowed?
So typically there are these what we call as data aggregators that work with multiple companies like PayPal to collate the identity of all different fraudsters.
Okay.
So PayPal also has agreements with them. We also capitalize on their intelligence because, like you said, right, like maybe the person is not yet a fraudster in my system, but he or she has already acted in a fraudulent way in some other system. So we use these third-party intelligence providers who provide us information, and there are like contractual agreements which dictate how much data we share in reciprocation to what data they are sharing. So, but I think I do agree with the broader view, right? Like be it in the credit world or be it in the fraud world, without using just your own intelligence about a customer, if you can capitalize on the broader market intelligence, it's always going to add value. So that is definitely an area we focus on. Yeah.
Last question, Venkat. I mean, in terms of, we talked about fraud, multi-million transactions, fraud, etc. In PayPal, for example, if you can share, what are the percentage of transactions that are fraudulent transactions and what percentage get detected or decline as fraud? In fact, there could be X percentage of fraud, but only some percentage of it get detected. So the rest of it, PayPal will have to take the tab, right, in that case.
Correct.
I mean, if you can share. Or you don't even have to talk about PayPal in general in this fintech world. That's better. I think let's not get into PayPal per se.
I think roughly, if I were to look at the industry, right, I think I would put anywhere in the incoming flow of transactions, anywhere between 5 to 10% can be potentially fraudulent. Now that's a huge number.
Yes.
Because think about it, right? In the fintech world, the actual revenue you as a company are making is only 2% of a transaction value, 2 to 3%. Right? Now, out of that, if 5% of transactions are turning out to be fraudulent, you're already running into losses, right?
Yes.
So the inflow could be this. But after you put your model and decline protocol and everything, the actual allowed volume of transactions that go fraud will be typically less than 1%. Somewhere between, say, like I would say, we use the term BIPs, which is like 1/100th of a percentage point. So when I say 50 bits, I'm talking about 0.5 percentage. So these are sort of considered as acceptable limits, because if there is anything that is more than this, then you're going to suffer huge losses as a company.
Okay.
Yeah.
So this sort of takes care of your margins and other things.
Correct. But this is a huge competitive differentiator, right? When I say I'm giving some rough approximate numbers across the industry, right? Now some companies will be better at this. PayPal particularly, one of the historical selling points of PayPal, or what I would call USP, is this whole safety aspect. Because PayPal has been around in the industry for more than 20 years, there's a lot of wealth of data about historical patterns of fraudulent transactions and so on, where PayPal typically does a more superior job of identifying good transactions and discriminating the bad ones. This typically therefore PayPal's approval rate for transactions is considered to be one of the highest in industry. Like and this is important for a merchant, right? Let's say you're an Amazon. Sure. You have to choose between two payment providers. You're likely to choose somebody who is more likely to allow a good transaction to happen. In that, PayPal typically has an edge. But within this paradigm of approving transactions, it's also able to keep the losses low by declining all the bad ones.
Coming to for the participants of the financial forensics course, what do you think their career is going to? How could they sort of leverage on this course to build their career? That could be my last question per se.
Definitely.
Since you've been in the field for so many years, how could they leverage their learnings in this course to build a career in this field?
Yeah, I think this is a very, very interesting field and a fast evolving field, right? Today, we are seeing, and especially being in India at this point in time, we are seeing this whole explosion of online transactions, online payment methods, call it UPI or call it, explosion of different forms of credit cards, buy now, pay later and whatnot, right? So there are multiple forms in which we are making online transactions today. And with that also, the probability of a transaction being fraudulent also is constantly going on, right? Now, in this kind of world, there are two things that are important. One, to have a strong foundation on how to identify fraud, what are the different fraudulent patterns, what are the different forms in which fraud can happen. And as long as you get that foundation in this course, one, your foundation is going to be very strong. Second, of course, this is a dynamically evolving field. So as long as you keep yourself abreast on the new evolving patterns, both from a fraud perspective as well as from a machine learning perspective, I think you can definitely have a very good career. There are going to be a lot of opportunities both for MNC fintechs like PayPal as well as local Indian startups which are operating in the financial space.
Thank you, Venkat. I think it was very nice interacting with you. I'm very sure the participants would have got quite a good amount of insights from this discussion.
Thanks a lot, Professor.
Thank you, Venkat.
I really enjoyed the conversation. Thank you.